thoughts, actually, that I gathered through this École des Ouches. One of the things that we discussed here is framing politics. I mean, basically, when we discuss economics, we discuss framing politics. I would like to recall something coming from my personal experience, is that politicians listen to economists, not because economy is something which is sound or right or predictive. It's just because they believe that they know what a euro is. They don't listen to engineers and physicists because they don't understand what a joule is. It's about as simple as this. No. So any scientist that wants to serve the political or the societal debate has, unfortunately, to fit his exact or whatever knowledge into something which is highly imperfect, which is the economy. So that's the first thing that I would like to suggest as a conclusion is what is the best way or the least worst, if I can say so, way to degrade something which is scientifically true into something which is just understandable. I would also like to recall that in democracies, we have a false opinion of what a political leader can really do. This is the conventional vision of where you work. Where you work in a company or in a lab or wherever, you have a boss, the boss gives orders, and you have employees that execute the orders. And if the employees don't want to execute the orders, you have some measures at hand that allows you to do something. Okay. And so we think that in the societal debates, it works the same. You have a boss, and the boss gives orders. Actually, the boss is not a boss. The boss is at the bottom. And the boss is below all the people that have desires. So you have people that have desires, plenty of people that have desires, and they have, of course, different desires, incompatible one with the other. Otherwise, it's not funny. And the guy there, wherever he is in a democracy, has to do something with all the desires. And even if you look at the energy debate, you have desires. So you want people that don't want this, don't want that, don't want this, and don't want that. So, and of course, when you sum and you don't need to use the movement of planets to frame policy or to frame societies. But if you think you do, then I'm going to give you a couple of simple conclusions, not very easy to implement though. The first one that I'm going to give you is that I love orders of magnitude, and each time that an order of magnitude doesn't fit with the result of a sophisticated model, chances are, that means that's where I'm ready to bet my own money, that the model is wrong. Okay. So one question here for you guys is, how do we get simple calculations into the scientific literature that generally puts a barrier to publish anything, which is that the calculation must be sophisticated. If you don't have a sophisticated calculation, you cannot be published. So basically, orders of magnitude and rules of three cannot be published. So the way you have to counter a sophisticated model that says nonsense is to design another sophisticated model, hoping that it will say something which is full of sense. But you just cannot refutate, does that exist? A sophisticated model with a simple rule of three. That is a true issue in the debate regarding energy or anything else. I'm going to give you a simple example. This is a rule of three comparing the system or a system which is mostly based on nuclear energy and a system which is mostly based on wind. When you use nuclear energy, you use a device which has a load factor of anything between 60 and 80%. If you use only nuclear energy, of course, you will use it for not base load, but also semi-base load. So the average load factor will not be 100%, let's say 70%. If you use wind, it's anything between 15% for a bad year in Germany and 25%, say in mid-latitude Europe, let's say. So you must install 3 to 4 times the power if you go for wind than if you go for nuclear. Then the lifetime of a wind turbine is, say, 20 to 30 years. The lifetime of a nuclear reactor is 60 years. Actually, it's conventional. Can be 40, can be 80. So you must renew your investment 2 to 3 times. If you are with nuclear, you can use the existing grid. If you go with wind turbine, you must add something to the grid. And when you look at historical ratios between the installed power, investment into production device and investment into the grid, you get something which is a 0.5 to 1 ratio. So you have to add that investment. Then if you have the present system where the power is dispatchable, you don't need to store much. You need to store a little, but not much. If you go to wind and you expect the train at 1:30 to leave at 1:30 a day when there is no wind, you must store. Okay, and storage, when you look at, there has been a full session on that at the last École des Ouches. The order of magnitude is a couple 10% of what you use over the year that has to be stored for anything between an hour and a month. So you have to have the power of the device, not necessarily the energy, but at least the power. Okay, that adds a factor 2 in rough figures, but the cost per kilowatt per installed kilowatt, of course, is higher here than there. So then you can divide by a factor 2 to 4, and if you perform the rough calculation, you end up with the fact that the total capex to go fully wind compared to going fully nuclear is in the range. It's a change of an order of magnitude. So any model that says that you can do the same at the same cost has a flaw somewhere. It has, and you don't need a sophisticated model to say so. You just need a rule of 3 that you will never publish anywhere, that you will publish nowhere. Okay.
Please. Non, non. On prendra les questions à la fin.
It's because the full cost of capital in Great Britain is 10% for nuclear. But that's it's different. I'm going to give you another order of magnitude, which seems to be important in the present debate. A number of you know this graph, I suppose. Who doesn't know this graph? Everybody knows? No? Everybody knows it? No? This is a graph from the last IPCC report, which combines a number of curves, giving you the average temperature increase in 2100 compared to pre-industrial periods, depending on the cumulated CO2 emissions coming from humanity from pre-industrial period to 2100. Okay? And you see that the set of curves basically describe something which is linear. In 2015, the cumulated emissions of humanity were 2,000 gigatons of CO2. So we are already committed to 1 point something degree of global temperature increase. And actually, if we're not lucky, and if we're in the upper part of the sensitivity of models, we're already over the 1.5 degrees that we have committed to in the Paris Agreement. And my personal bet is that we're already over. That's lost. I mean, it's no need to do an IPCC report on the consequences of 1.5. I mean, it's already over. If we want to stick to 2 degrees, it means that we must not emit more than 3,000, of which 2,000 have already been emitted. So there remains 1,000 to be emitted. For humanity, which is 7, 8, 9 billion people. So that is on average 3 to 4 times more numerous than the number of human beings that we were in the course of the 20th century, during which we emitted this 2,000 gigatons of CO2. So a simple rule of 3 is that the carbon budget of somebody living in the 21st century is a 6, if we want to stick to the 2 degrees, of what it was for somebody living during the 20th century. Okay, you have to divide by 6. Actually, we have to divide the emissions by 3 by 2050, so basically by the time my kids are my age, if we want to get the 2 degrees. If you compound interest, you realize that starting tomorrow morning, it means minus 4% per year. So I have looked at, did we in the past perform minus 4% in the CO2 emissions? We did, 3 times. We did it once at the maximum of the 1929 crisis, 1 year. We did once in the course of the Second World War, the year of the destruction of Germany and Japan, once. And we did once thanks to a crisis in 1997. So otherwise, we're just unable to combine lowering CO2 and growing economy. We're just unable to do this. So it will need something more than just wishful thinking to believe that we will be able to do so, and I will come back to this later. Something else that I would like to suggest in the same idea is that if there is a sophisticated model that doesn't match a basic fact, you just dump the model. Okay, you dump the model. You will never get just one picture published in the scientific literature that allows to dump a model. Never. So Mireille showed this already. I had also the intention to show it. So this is, again, the price of oil. This is a prediction on the price of oil. You do this once, twice, dump the model. You should never publish this. Never, ever. You dump the model. Where do you get this graph published in the scientific literature so that you say that the model can be dumped? Nowhere. There is no place for that. Something else, okay? If you have a general, that's basic logics. Okay, if a general assumption is contradicted by just one example, then you are not allowed to use the general assumption in a model. Okay, very simple. Again, where do you publish examples? So I'm going to, something that you've all heard of is elasticity, and I know a number of models regarding energy that use long-term elasticity between energy in volumes and prices. Okay, one of which being Paul's of our friend Patrick Criqui. This is a simple plot giving the volume of oil consumed in the world and the price per barrel in constant dollars. If there were a long-term elasticity between prices and volumes, the dots should follow something resembling this. You have more, cost less. You have less, cost more. You have not such a pattern. Actually, it's not bijective. So you cannot say, give me the price, I will give you the volume. You just can't do this, okay? And if you have a function in a model which is not bijective, you just cannot use it. You just cannot use it, okay? Actually, what you see here is basically 2 unelastic regimes. One in which you have a price which is constant and the volume does whatever it wants. One where you have a volume which is almost constant and the price does whatever it wants. And then, again, with the 2 regimes. Another assumption being if we put into motion something that is fighting climate change, we will necessarily get results to fight climate change. So this is the CO2 content in the European Union, the CO2 content of the GDP over the last 50 years. Okay, constant dollars plotted against CO2 emissions. As you know, the European Union has been at the forefront of action against climate change, etc. So we have divided by 3 the carbon content of dollar of GDP. And this is the big bad USA, boo, that have done exactly the same thing. So things must probably be more complicated than we just declare that there is a political will and we will do what needs to be done. Okay. Something else that I would like to suggest. There is something which is very nice with energy, is that 1 equals 1. I mean, the law of conservation means something very simple, is that if you have energy flowing into a system, and the system is at equilibrium, you must have the exact, not something 0.5, whatever, the exact same amount of energy flowing out. So energy, you can always start to explain energy with boxes and arrows. Boxes and arrows. Where do you publish boxes and arrows? Nowhere. I mean, there is no scientific literature accepting boxes and arrows. No one. So I'm going to give you my interpretation of energy with boxes and arrows, basically. Because of the law of conservation, again, using energy is actually basically putting energy into a converter. It's extracting energy from the environment and putting it into a converter. You cannot create energy because of the law of conservation. You just can convert it. And actually using energy is using a converter. It has been very well explained by Astrid in the course of the energy transition. We changed converters and we changed energy supply. The only converter that we had in historical times, well, actually in prehistorical times, was ourselves. We are an energy converter. We eat, we're going to do so in a couple of minutes, and out of this food, that is energy, we get motion and heat, basically. A little intelligence sometimes, not too much. Then, thanks to engineers, but thanks to the fact that nature has endowed us with stocks, because if you take an engineer and you put him into the vacuum, the interstellar vacuum, you will not get an economic system. You will not. You need natural endowment to have something more with the brain of the engineer. So we found converters, and using more and more energy is using more and more machines. That's what I want to stress. So everywhere you see energy, you tick the word and you replace it by machines. And then a number of things become very logic. Look, for example, the power of a human being, depending whether he's using his arms or his legs, is anything in the range of 10 watts to 100 watts. Schwarzenegger was a little over when he was young, but 10 to 100. A single tractor has the same power that 600 pairs of legs, which explains why, when you have energy flowing into the agricultural sector, you can remove peasants and put them into factories and cities. A single public works machine replaces thousands of pair of arms, which is why Notre-Dame de Paris was built in a century, when a tower in La Défense today needs 6 months, because of this and all the other machines. A truck driver is 4,000 times less powerful than the engine of the truck. The train is more powerful than the truck. The plane is more powerful than the plane, sorry, yeah. And a steel mill has the same power that 1/6 of France, 10 million people, to which you would give hammers. So you have energy and a steel mill, and you replace 10 million people. So when you look at the energy input per capita, or the energy consumption per capita in the world over 1.5 centuries, what you realize is that energies have piled one on top of the others because machines have piled one on top of the others. We don't want to get rid of machines. We want to have more machine consumption max. I agree. So on top of machines that did this, we added machines that did that. Okay. And now we have on the energy supply that little thing over there that we would like to replace all the rest in 35 years. Actually, the bulk of what we use is carbon. And that carbon has provided us with mechanical slaves that is equivalent to 200 times the power of humanity. Okay? That's what energy has done to us. Multiply the productive power of humanity by 200. Of course, we don't want to waive that. I'm going now to give you a simple calculation on whether it's possible to substitute machines by work. You know, it's something which has been discussed here. I'm going to give you, again, a simple calculation. If you take a tractor plus the driver plus fuel, you get 600 times the mechanical power of the driver. So you'd say, okay, let's suppose I use less fuel. I'm going to have not the tractor, but half of the tractor, and I can replace the other half by 300 workers. So I can create work. Okay? That would be true if in our economic system, the cost of a worker was 1 on 300 the cost of half a tractor. Okay? If it's not the case, if I get less fuel, I mean I get half the mechanical power, half the production, and half the tractor drivers. Which is why in our present societies, when we have a decrease of the energy input to the society, we have a decrease of the jobs and not an increase of the job. Because the difference in productivity of a machine, because when we said the productivity of work has increased, actually it's because we have added machines to people, and what we put at the bottom of the ratio is still people. It is still people. We do not add up people and the mechanical power of the machines they use. It is still people. We count machines for nothing in that ratio. And I'm going to give you a couple of examples. This is the energy consumption. That is the energy availability, actually, for Spain. You can see that it went through a sharp maximum in 2007. Who knew it? Okay, 4 people. And the reason why is because conventional oil production peaked in 2006. It's been said here during this. And so because of that, the shale oil boom in the US was not enough to supply more oil to the oil importers everywhere in the world. So all the OECD zone went through a maximum of the oil supply in 2006. Spain was heavily dependent on oil. So it's the country in which the global energy supply declined the fastest because of the dependency on oil. The rest was not subject to the same constraints. Now, this is the population, the employment to population ratio in Spain. It is not the opposite of the unemployment ratio, because to be unemployed, you have to declare that you want a job. This is something which is much more basic. It is the fraction of the population aged over 15 that has a job. That does have a job, okay? And you can see that in 2007, began to decline. And and what you can see also here is the normalized evolutions of energy in green and the GDP in blue in Spain. And you can see that the maximum of the energy supply is before the maximum of the GDP. So it's not you have GDP growing because of whatever, and when it stops to grow, you have energy, which is a commodity, which is bought, that declines. It's first, you have a constraint on the energy supply, and then you have a constraint on the output of machines, that is the GDP. Very simple. You will get that published nowhere. It's just impossible to submit an article saying this. Same thing now for Italy. Maximum. You see the employment to population ratio. Maximum, and Berlusconi won't change that. And here, same thing. You see the maximum for the energy supply and the maximum for the GDP shortly thereafter. I'm going now to show you the US. You see the US went through a maximum of the energy supply in 2007, notwithstanding shale oil. And here is the drop to population ratio in the US. And you can see that they are far from having recovered the pre-crisis level. Now, something that I want to stress also is that a number of you guys, of course you have a job, but you also read the paper. I have always been stricken by the fact that my father, who was a physicist, put always more trust in what he read in the paper than what he read coming from his own colleagues. So he could spend hours understanding why his own colleagues in his own field, Colombian systems with 3 bodies or something like that, I never understood anything, could spend hours understanding whether his colleagues were right or wrong. He would never question himself on whether what he read in the paper was right or wrong. Should have done the opposite. I mean, the error production process in the papers of his colleagues is far, far, far more, controlled than the error production process in a paper. There is no error control in a paper. So an article that you read in a general paper is never something that you should trust by default. Never do this. If you do this, you're sure to go in the wall. Sure. For example, when you read an interview, actually what you read is not the position of the person who has been interviewed, it's the position of the journalist that made the interview. It's what he writes. Okay? Sometimes it's been checked by the person interviewed, sometimes not, sometimes you don't know. Let's say, for example, that you take an assumption in the paper, which is that we have witnessed a renewable boom in the last 15 years. This is the actual figures. So this is the actual increase or decrease of each energy in the world over the last 15 years. And what you can see is that in the last 15 years, we have witnessed a fossil fuel boom. This is what we have seen. Actually, the fossil fuel boom, the coal boom, has been 20 times the solar boom. You say, okay, it's over the last 5 years. Let's take the last 5 years. This is the change in electricity production in the world over the last 5 years, 6 years actually, and what you see is a fossil boom. So never trust the paper. One last thing, our ministry, Nicolas Hulot, recently said something which is very sound. He said that if something He didn't say this, actually. He said that there was an objective in France which would not be achievable. Well, I'm going to give you a general law. You don't change the laws of physics by voting in an assembly. It's not because you vote in an assembly that it will happen. Okay? And actually, you'd better know the laws of physics because you cannot escape them. Whereas you can escape the laws of humans even though you don't know them. You can. You just ignore them. You don't apply them. Nobody catches you and nothing happens to you. Okay, so you can escape the laws of humans. You cannot escape the laws of physics. This is a vote in an assembly. This is the Sustainable Development Goals of the United Nations. So you see, this is Alice in Wonderland. Everybody has to eat. So if you're an economist, you're happy because you get rid of poverty, you have growth, you have less inequalities, so everything is fine. But you're also happy if you care about human health, because people are not hungry and they're in good health. Now you're happy if you in this room, you perform a teaching of some kind. You're happy if you care about gender equality. You're happy if you like to drink water, which is actually something important. You're happy if you're elected in the local community. Well, everybody is happy, okay? Yes. So you should be happy if you care about CO2 and if you care about the economy. Now, this is another plot very close to what you have seen. It's for the last 50 years, CO2 emissions plotted against the world GDP. Do you believe, when you see that we are going to click our fingers and have green growth? Just because the General Assembly of the United Nations decided to do so. I believe the physicists in this room, or part of the physicists in this room, say, at least I doubt it. At least I'm going to check that it's possible. It's not the way politicians do. You have plenty of laws coming here and there, and we have one in France, which is in favor of green growth. Okay. And the last thing I'm going to say is that understanding the past is not a guarantee to frame a correct future, but the reverse is true. If you do not try to understand why things have been so in the past, you're absolutely sure to frame something which is not going to work for the future. And I'm going to conclude on why on earth have we gone from renewable energies that were the only energies that we used a couple of centuries ago to fossil fuels that seem to be such a problem today? Were our ancestors totally stupid? Out of their minds? You know. I'm going to give you this little example. Let's assume that you take a cube of 10 meters of dimension of air blowing at 80 kilometers per hour, 45 knots, and that you put it through a wind turbine. You're going to get kinetic energy. Okay, I assume for this that the yield was 40%, maybe it's 50%, doesn't change much. Well, the amount of energy that you are going to harness doing this is what you have into 3 milliliters of oil. 3 milliliters of oil. Okay. The cost of doing so, which is actually the amount of human labor, because I recall that money pays only men. Money pays only men. Money doesn't pay for the natural resources that are all free. The wind is free, but oil is free. Nobody paid a single cent for oil fields to exist. No one. You can sit on it, if you're lucky, and then you get money from that. But you didn't create the oil field, okay? The creation of the oil field is free. The creation of the coal mine is free, and the creation of the copper mine is free. All this is free. 30 seconds. We started 15 minutes late. What I'm just saying is that this represents actually the amount of human labor. That's how you should see it. Euros or dollars is human labor, basically, okay? And rents, but human. It's human revenues. If you decide that the train will run only when there is wind, cost you 6 to 8 cents. If you decide that it will run even though when there is no wind, it costs you must multiply by 3 in rough figures. On the other hand, the cost of a kilowatt hour of oil, the technical cost, not the Mireille Martini cost, but the technical cost of extracting a kilowatt hour of oil from the ground is 0.3 cent. And you already have the storage function there. You can already move when you decided to press the pedal on your car. Okay. So there is a 50 to 100 ratio of human labor and rents, of human labor. I don't care again about the natural resource. You must work 50 to 100 times more to extract energy from the environment and give it to the society if you do this, than this. This is why we went from renewables to fossil fuels. And this is physics. So we won't reverse this at no cost. At least I don't believe so. And that's it.
Two questions? Two questions?
Nuclear power is a secondary issue in this debate.
Yes. How about creating, like, if these results are not publishable, how about creating a journal of simple results, journal of orders of magnitudes, and publish our own things?
Actually, it was exactly one of the outcomes, in a way, of the discussion that we had yesterday on the International Panel on Energy Science. We should. Someone should. Someone should. But I mean, it's one of the nuts here.
Hello. According to your talk and your thought, it's almost impossible to decouple GDP and energy consumption or CO2 emissions. Starting from that, the only solution should be to reduce GDP, right? I mean, so for me, there is no other way than degrowth. So why are you still not an explicit supporter of degrowth?
I am an explicit supporter in the way that I believe that we cannot avoid it. I subscribe to the conclusion that it's impossible to decarbonize without triggering a recession. But what I believe also is that talking to people who know what they know, in a democracy, you will never enforce that in 35 years' time. So the best you can do is not tell them. I'm serious. I believe that the best you can do is not tell them. And the only way that people do have their revenues that decrease by 1% per year without telling them is that you have less inequalities, because otherwise people just react to that and they vote for who they vote right now in Europe. Brexit here, Berlusconi and Beppe Grillo here, Marine Le Pen and Mélenchon in France. I mean, all this is consistent. No, all this is, it goes, yes, it's the same thing. I mean, I consider that I suffer more than my neighbors. It's based on this. It's my view. And Trump in the US. I mean, all this is the same process. It's all the same process. It doesn't materialize the same way, but it's basically the same process. And so what I say is that we cannot avoid it. So one of the things that I suggest is to dump all the models that assume by construction that we will decouple things. Should dump them all. And start from the very beginning again with simple things. That's what I believe. But you will never, I insist on something, you will never sell a structural recession to a democratic society in the present times. You will never sell it. So it's not something you can implement through an election.
But you completely misunderstand degrowth as recession. It has nothing to do. It's completely different.
It is a recession, among other things. It is. It is a recession, among other things. If you replace a car by a bike, you replace something which is worth 10 or 20,000 euros by something which is worth 5,000 euros. So you chop down 10,000 euros of production process. And you say, okay, I'm going to replace it by the production somewhere else. You have to be sure that the production somewhere else is much less energy intensive, much less carbon intensive, and actually in the way Roosevelt viewed trains that pass by counting tables and chairs, it is a recession. In this way it is.
There was a question up there. A very short question and the last one. It is the last one.
On one aspect, I appreciate your talk and your work, and I agree with you 100%. We have to put our points down to something you can understand easily, as you do. I appreciate it a lot, because on the basis on this data, we can start communicate and discussing. And that's why, bravo, what you do.
Thank you.
So, this is the last word. So we close the session. We thank you all for having come here, and we hope to see you some other time. So this session takes place every 2 years. Why every 2 years and not every year? It's because you should have time to work back home. But if you work a lot, then maybe we'll have this session every other year. So every year, yeah, no, sorry. Pardon? Yeah, if we have sponsors to organize it.